Welcome to video 3 of my series into Microsoft Fabric DP-700. In this video I will talk about Onelake, storage formats and performance optimization. Onelake is Microsoft Fabric's built-in data lake. It works as one central storage pool for the entire organization. It is built on Azure Data Lake Storage Gen 2, but Fabric presents it as a single logical place to store data. You can store many types of files in Onelake, including tables, CSV files, JSON files, PDFs, and images. You can hold structured, unstructured, and semi-structured data. For analytics, Fabric mainly uses Parquet. Parquet is column-based file format which makes queries faster and reduces file size. Fabric also uses Delta on top of Parquet. Delta adds ACID transactions, which means data changes are reliable, consistent, protected even if a process fails. It also adds a changelog and the ability to query earlier versions of the data. Parquet and Delta and why they matter. Parquet stores data by column instead of row. Queries only read the columns they are needed, which improves performance. Column-based storage compresses well. This makes queries faster and lowers storage costs compared to row-based formats such as CSV. Delta Lake adds transaction log that records all changes. This provides ACID transactions so that data stays reliable even if a process fails. Delta supports schema rules. These allow you to enforce data structure and update it safely when required. Delta enables time travel. You can run queries against earlier versions of the data for auditing, debugging, or reviewing past results. Performance optimization. Adding data over time can create many small Parquet files. Too many small files makes queries slower. The optimize command reduces this problem by merging small files into larger ones that are quicker to scan. Optimize can also apply Z-order. Z-ordering arranges rows so that similar values are stored closer together. For example, you could have year and you could have years close together. So queries that are searching by year could quickly go to the year in question, such as year 2022, and not look at year 2021. This improves queries that filter out those columns because the engine can skip large sections of the data that is not needed. For example, optimize sales order, Z order by customer ID makes queries that filter by customer ID faster. Performance optimization. Vacuum. Delta tables keep older versions of files to allow time travel queries. Over time, older files build up and take space. The vacuum command removes files that are older than the retention period you set. For example, a vacuum sales order retain 168 hours removes files older than 7 days. Once a file has been removed by vacuum, you cannot time travel back to get it. Run vacuum only when you're sure the older versions are no longer needed, as vacuum is permanent. So some key things to remember. Parquet files work best when each file is between 100 megabytes and 1 gigabyte. Files smaller than 100 megabytes can slow queries down, and files larger than 1 gigabyte can be harder to move and manage. Run optimize regularly to merge small files and keep query performance consistent. Fabric applies data skipping automatically, which avoids scanning files that do not match the query. Z-order makes data skipping more efficient by grouping similar values close together on disk. Keeping tables maintained with optimize and vacuum ensures faster queries, lower storage costs, and predictable performance. Now we will cover 5 questions which I believe are likely to be on the DP-700 exam. Now we will cover 5 questions which I think are likely or similar to be on the DP-700 exam. Question 1. Which file format does Fabric use for fast analytics and compression? A. CSV, B. JSON, C. Parquet, or D. XML? And the answer is C. Parquet. Parquet is correct because it is column-based, compresses well, and is optimized for analytics. CSVs are row-based, and JSON and XML is not what Fabric uses. Question 2. What benefit does Delta Lake add on top of Parquet in Fabric? A. It makes files editable in Excel. B. Adds ACID transactions and time travel. C. Deletes old data after 1 day. And D. Converts data to CSV. So the correct answer is B. Adds ACID transactions and time travel. So Delta provides ACID transactions, a transaction log, and time travel for previous versions of data. A is incorrect because Delta Lake does not make files editable in Excel. C. Delta does not automatically delete data. Old data is managed using vacuum. And D is incorrect because Delta does not convert Parquet to CSV. Question 3. What does optimize command do on a lakehouse table? A. Updates all SQL statistics. B. Compacts small files and can sort by columns. C. Splits large files into smaller ones. Or D. Moves data to CSV. And the answer is B. Compacts small files and can sort by columns. So B is correct because it merges small files into larger ones and can cluster rows using Z order. A is incorrect because Optimize does not update SQL statistics. C is incorrect because it does not split files. It combines them into larger ones. And D is incorrect because it does not move data to CSV, into CSV. Question 4. Why would you run a vacuum command on a Delta table? A. To rename the table. B. To remove old file versions. C. Vacuum the SQL cache. Or D. Downgrade Delta format. And the correct answer is B. Vacuum deletes old Parquet files that are no longer required. So A is correct because it does not rename the tables. C is incorrect because it does not clear SQL cache. And D is incorrect because it does not change the Delta format. And question 5. What is the purpose of Z ordering a table by a column? A. It deletes data in that column. B. It clusters rows by column values. C. It encrypts the column. Or D. Converts it to row storage. And the correct answer is B. It groups similar values together on disk, so queries that filter by that column are faster. Z ordering does not delete the data. Z ordering does not encrypt data. And D is incorrect because Fabric continues to use column-based Parquet storage and does not use row storage. So that is the end of video 3. Thank you for watching.